Hey everyone, welcome to today's session. We'll be diving into the important and interesting topic for SAT maths, scatter plots, and line graphs. These tools are not just for the SAT, they are used everywhere, from amazing sports statistics to predicting business trends. So let's get started. Introduction to scatter plots and line graphs. Let's start by understanding what scatter plots and line graphs are. A scatter plot is a way to visually display the relationship between two variables. For example, think about how study time and test scores might be related. A line graph, on the other hand, shows data that changes continuously over time, like how your phone battery percentage decreases throughout the day. On the SAT, these graphs are essential for solving questions related to data interpretation and trend analysis. Determining the line of best fit. One key concept for scatter plot is the line of best fit. This is a straight line that represents the trend in the data. Imagine drawing a line to the center of your scatter plot points and best represents their pattern. How do we find the line the best fit? Use tools like Desmos to input scatter plot data and visualize trends. Check the axis and scales. Getting them wrong can lead to errors. Test different equations to see which one aligns best with the data. This is an important skill for SAT questions where you need to choose the correct equations for a scatter plot. Don't worry, we'll practice it shortly. Identifying graphs of point motion. SAT math often includes questions about motion scenarios such as how a car moves or how a ball bounces. Graph can help visualize these situations. For example, a graph can show how an object slows down due to friction or how it hides changes during motion. Tools like Desmos are amazing for simulating real world scenarios. You can literally watch a graph in motion to understand what's happening. As we go through examples, I'll show you how to relate these graphs to real SAT questions. Practical exercises with Desmos. Let's talk about using Desmos practically for SAT success. Input the data, that is your step one. Enter the scatter plot data into Desmos, making sure the axes are set up correctly for the SAT question. Analyze the trends, look for patterns, and test lines of best fit. Apply insights, that will be the step three. Use the graph to solve SAT style questions. During practice, always think of these graphs as tools that help you quickly analyze data and pick the best answer. Let's have a look at this particular example which is in front of us. It's a very beautiful example. It says that the scatter plot below shows a coffee stand ice coffee sales as in dollars and high temperature T in degrees Celsius in 10 different days. A line of the best fit for this data is also shown, which the following could represent the equation of the line of the best fit. Now, four options have been given. The scatter plot shows a positive correlation between temperature and iced coffee sales. Use the provided graph to determine the correct equation for the line of best fit. Now, I'll see that there are multiple points over here. To figure it out, the line of the best fit, you can take two corresponding points which are on the line of the best fit. Right. So the best way is that you can choose any 2 points. For example, I'll be choosing one point over here. For example, this point is 30 as x-axis and 1000 as y-axis. Another point I'm taking at 1100 points. So that is 35, comma 1100. By the help of regression, we can directly find the line of best fit. Let's work on that. Now, how to apply the regression over here? We'll put the table as we're doing from the last couple of sessions. So it's 30 and 1000. Another one is 35 and 1100. Now you'll see that what is happening. I'll say that y1, a sign of regression, ax1 plus b. Now I'll see that the values that I get, the value of a, that is slope, I get is 20. And the value of b I get is 400. On the equation, you will see that 20 over here is the slope and 400 is the y-intercept. That means B will be the correct answer. Okay, moving ahead to the second example. This is more or less a very practical example. It says the diagram shows a wheel with a mark point X on its edge. You can see that X point is above the wheel. Rotating as it rolls on the ground, the wheel starts rotating at a constant speed and then deaccelerates over time due to friction. Which of the following graphs could represent the vertical distance between point X and the ground as the wheel rotates, as it deaccelerates? Now I will see that the options are very much interesting. It says a sine wave that gradually decreasing amplitude. That is the first option. The second is a straight downward diagonal line. The C part says a series of triangular peaks with decreasing heights and a sine wave with constant amplitude. Now we need to understand that which exactly it is. So for that, I have framed a graph already. It says, now let me give you a better point of view before. So imagine a wheel with a point marked on the edge. As the wheel rolls, the point moves in a wave-like pattern. Definitely. The graph represents a vertical distance of the point from the ground. Since the wheel slowing down, the wave amplitude decreases. Which graph do you think fit best? So I have made a graph. Let me show you that. If you look at towards this graph and look forward for this presentation over here with respect to the time. So you will see the sine wave formed and you will see that the amplitudes with respect to the time actually gradually decreases. So what is happening over here that this distance is actually lesser than this distance. So as friction goes more, so the sine wave have gradually decreasing amplitude. So definitely option number A will be the correct answer in this scenario. Option A will be the correct answer. So that wraps up our session. Today we covered what scatter plot and line graphs are, how to find the line of the best fit, and how to use graphs to model motion scenarios. I encourage you to try more examples using Desmos. It's a fantastic tool for visual learning. Thank you for your participation, and I hope that you will be feeling more confident about tackling these topics on the SAT.